introducing me, and I will introduce actually the geological maps, explaining why they are important and how much they are important for the human being on Earth, and why they are important on planetary body exploration, as well as their meaning, how we can read them. So here you see the first geological map, modern geological map ever done in the 19th century by William Smith in 1815. And you see clearly that there are different colors, different symbols. So a geological map is not so much different, if you want, from a musical score. Even the musical score have their own symbols, and the musical score symbols gain their meaning through time, as well as the geological maps. Indeed, the geological maps are a representation of, planar representation of the geological material that you see in a landscape and their ages. And through the ages, it's possible to tell the geological history of that landscape. And through their geometrical organization within the map, it is possible to understand what it is, the composition and the structure underneath the landscape. So as I said, you can see symbols and color that gain their meaning through time, like a musical score. And like a musical score, everybody will know and how to sing, can sing something. A few of us can read the musical score, and very few of us are able to compose a symphony. And the same for geological maps. The geological maps, every one of us can perceive that they are nice with beautiful color symbols like these ones. A few of us are able to read them, and very few of us are able to make their own geological map. So this school aims to give you the tools and the workflow for beginning your geological mapping symphonia. So we can start looking at modern geological map of the Alps here, and you see in Dolomites, you see that there are even nicer colors, and these colors have different meanings that are in the legends that you may see in the two sides. So these sides are telling you the composition of the rocks, the environment in which they were deposited, and so forth, and the ages. So the colors, the first things to explain are colors. Color on geological maps are different with meaning. The first meaning for colors in geological maps are the geological environment in which the rocks were formed and the sediments were formed. So for example, we may have the volcanic environment. Normally, the reddish color means something related to volcanism. It's not always the same, but we may have this distinction between colors. So we have even possible colors for coastal environment, alluvial plain, as you see to the right, or even you may have color for atoll in the middle of the ocean. Know that atoll are carbonatic rocks that grow up, and afterwards so they can be exhumed in mountain beds. And we see, for example, a beautiful example of a mountain massive like this in Sella and Dolomites, which is inside the map that we have seen before. So if we want to see the atoll, we can give a color for giving that kind of explanation. Another explanation for color is for sure the stratigraphic relationships. You know that sediments are deposited on top of one another. So it means that the younger sediments are upper and the older one are underneath. So we may find color for indicating the relative ages between these different maps. Sorry for this slide, because there is some setting up that has not been fixed. In any case, you see that these layers are indicating a relative age. So we can use the color for giving the age to the geological units that we see on the map. So if we start telling the story of the Dolomites that we have seen before, we can start from different colors, these volcanic rock, for example, that are red, and then have a series of layers and up to the atoll that were formed in the Dolomites more or less 237 million years ago. And afterward, we may find other rocks that are actually volcanic rocks that could be formed on top of the atoll. And this is actually what it was seen, and it is actually clearly visible on the rocks that are outcropping. And then we may have, again, sinking of this area with a shallow water environment, and still the mountain. And again, we can a deeper landscape with we can have an uprise again with alluvial plains, and finally a landscape with deep water with different rocks. And at the end, for having everything exhumed, we have to deform the landscape. We have to deform this stratigraphic sequence. And indeed, this stratigraphic sequence is the key for understanding the geological map. So the different colors that we see here are the geological environment in which these sediments were formed, and the ages that can be read from the stratigraphic sequence that we see here. And in addition, all of these can be deformed while we have the exhumation of the Alp that in this area started at around 25 million years. And this exhumation causes deformations. And these deformations are the symbols, the linear symbols that you see in the map, these blue ones, for example, that are plane of mutual movements of two closed blocks of volume rocks, and may even cut the geological map and see what it is underneath the landscape. And we have what we call the geological section that will be one of the topic of our school either. So on this geological section, you see clearly this kind of faults. Sorry, I have to stop a moment because I have something that I have. I have something, the setting that is not working well.
We can still see your screen.
Okay, it's fine. So as you see here, we see, as I said, the deformations of the stratigraphic sequence and the exhumations. And this deformation exhumation is visible, as I said before, through these kind of lines that are planes of mutual movements between volume rocks. And here in the geological section, you see these faults with the volumes separated by these planes that here are in a geological section. And also you can see the deformations of faults, like these ones, for example, underneath important in Dolomites. So in this way, it's possible to understand that for understanding geological map, it is important this stratigraphic column here that you see to the right, which is the key for understanding the colors, and the composition are well explaining within the legends. And afterwards, we have the geological section that, together with the symbol that explain the deformation that this landscape had. So if we want to translate everything in a planetary geological mapping contest, we can start from the map by Schumacher in 1960 that was made from a telescope by a geologist and even astronomer, I would say a comet hunter, and an important field geologist. So in this case, you don't know actually clearly the composition of the rock, but you can understand the environment that is clearly an impact environment in this case. And you can even understand the overlapping relationship between some material with other. Here, for example, we have the ejecta that has been formed during the impact that are covering some other material all around. So we can do still morphology, and we can see stratigraphy, seeing some kind of morphostratigraphic sequence. If we go more in detail in more modern map of the interior of this crater, you can see Copernicus crater, you can see clearly that you see distinct different units with different colors. And so you see the rim with the scarp and the peak inside, and then you see some material that is infilling the map itself. And again, in the geological section, you see the deformations, and in the geological section, you may see some very simple, if you want, stratigraphic relationship between different areas. In this case, the volcanic ejection are this yellow material here, for example. And even in more difficult, more complex geological map, like this one, for example, by Ivanov in 2018, we see that still with different kind of units and different stratigraphic sequence. And here we see the ages in terms of epoch of the units itself. And here to the right, you see the different moment in which the different units of impact units are formed during the evolution of the moon. So again, we have the same concept that on Earth, but we lack some information about composition. Actually, on the planetary geological map, we can see spectral variability, or how the material affects the light in different way, in different wavelengths. And so we can have an idea of the different composition of the units. And this is the case in which we see a morphological map to the left, like the other one in Sikorsky crater on the moon. And here we see a composition that gives you some important information about, an image in which you see some important information about composition on the same map. So there could be even cases in which the two things can be integrated. And this is an example, very recent example by writing to 2019 and still in preparation and in press. And we have an area here in Mercury, which beautiful impact craters. Then we have this kind of quite complex composition spectra. It will be explained, at least theoretically, during this week, how this was done. And afterwards, these two information were integrated in a unique geological map, but that it's, in this case, closer to the geological map that we have on Earth. So the main point here, now that we have understood how geological maps are, which are the symbols, the color, and their meaning, we have the important question on why geological maps are important for the human being on Earth. For sure, they are important for science investigation, okay? For sure, they are important for research and mining exploration, for research evaluation, exploitation, and management, for the hazard and risk assessment, for the land use and infrastructure planning, tunnels, roads, buildings, towns, and then for environment safeguard. So for all these reasons, all the nations in the world have their own geological survey that has the aim for producing geological map. Because any nation that has not a geological service has a population that are living in a lost country and put their life in risk. So this is why the geological map are so important on Earth. So if we want to translate it on planetary context, why they are important. So for sure, for science investigation, for sure, for in situ research, exploration, evaluation, exploitation management, if we want in the future to think that some planetary body can have a stable settlement and can be used as a first step for even more important explorations of the solar system. For sure, they are important for determining the risk and the hazard of a given landing, roving on a planetary surface. They are important for making the infrastructure and how to use the land in which you land. And finally, not environment safeguard, but we have planetary protection. So the way and the distinction of area that could be contaminated by us or from which we can be contaminated. And so for all these reasons, the geological map are equally important on Earth or other planetary bodies. So that's why in our Pangea course, ESA Pangea course for astronauts, all the astronauts have to work on the geological maps. Here we see to the left the astronauts working on a lunar geological map, here on indicating a possible traverse in a lunar site for future possible landing exploration. Here, exploring the stratigraphy of a given geological map. And here, looking to a geological map of an important impact in Europe. And on the lower right, we see the astronauts working in virtual environment, because we aim in the future to make geological map being more or less there, using the in situ images from rovers. And this is something that should be on which we should onward. On this topic, there will be a specific lecture in the next days. If we want to go even farther in time, and we may think that geological map can be in some way projected in a kind of augmented reality landscape for astronauts to be to select the sites to be studied more and to be investigated more. And when we have the landing, if we consider that on the basis of geological map, we can infer the subsurface of a given landscape, subsurface structure and composition using the augmented reality. Even the astronaut, when he will be, for example, on Mars, they will be potentially able to see not only the geology in the landscape, but what it is underneath the landscape, and eventually change it on the basis of their observations. For all these reasons, we had two important European projects. The one that ended last year, which was PlanMap, that has the aim to produce innovative planetary geological map on Moon, Mars, and Mercury. And from the last years, we had this new project, which is Aeroplanet 2024, that has been already well explained, in which we have this infrastructure that aims to foster and support planetary geological mapping in the future. And this is why we have this winter school. This winter school is organized by Aeroplanet 2024 and GMAP with support from the University of Padua. So winter school organization, we have organized the winter school in 5 days. In the first one, we have some theoretical explanation like this one and on terrestrial planets. Then we have practical activity on geological mapping tools and workflows. Afterward, in the second day, we have theoretical activity about crater chronology, how to make age determination of a given planetary body according to the crater density. Then we have practical activity on how to map make geological map of lunar maria or Maria. Then on the third day, we will shift our interest on Mercury morphology and its composition and the geostructural mapping of the Mercury surface. So on a geological map, we integrated with particular attention on structure and deformation that I have already talked about. And finally, we will explain Mars sedimentary environment, and using this knowledge, we will apply it creating a geostratigraphic map of a chaotic environment Mars. And finally, we have the geological sections, how to produce them. And on the practical activity that we have, there will be the workflow and the tools for making geological section and even the final layout before printing the map itself. All the videos will be available through Indico for asynchronous attendance of the different practical and theoretical activities. So what is the novelties of this school with respect to the last year? So we have another one last year. In this case, we focus more on planetary geological interpretation. So how to recognize features, how to map them, different environment, different planetary bodies. We have a new plugin for geological mapping, which is Mappy. It was already there in the last session, but now it's much more improved and more interesting. Then we'll focus to the complete process of geological map, not only just interpretation, but even how to include the geological section, as I said, final layout. We have a continuous support using Discord for help desk for each activity. So if someone is not able to speak or ask to the trainer, can just directly write his question, his or her question to Discord. We have several invited speakers that are deeply involved in planetary mapping activity, either for making the tools, the workflows, organizing planetary mapping project, or even making their own map. So another last point is on the basis of this school, we would like to begin a community mapping project with follow-up with periodical meeting to support potential final submission to GMAP database. So it means that if you have your map, if you want to continue the map that you have started during this winter school, you will be supported in order to have it completed and be submitted in GMAP database, or eventually even, if it depends from your aims, eventually even be published in a given journal about maps. It could be Journal of Field Trips and Maps that is held by the Italian Geological Society and the Italian Geological Survey. So if after the school, do you think that the school was useful in terms of resources, software, tutorial, documentation, and even theoretical lecture, we would appreciate you to acknowledge it directly, just recalling 2024 and the GMAP activity and the grant agreement under which it was established. So, so thank you very much. And I think probably after this lecture, not everything will be clear. You could be quite skeptical, but on some places, but we hope that during the winter school, everything will be much more clear for you and you will be able to make your geological maps. Thank you.